development IMPAS-based drugs is hindered because of cytotoxicity and metabolic instability of IMPAS. One strategy to handle this challenge is IMPAS macrocyclization, which improves pharmacological properties and bioavailability of antimicrobial peptides. Cyclic peptides formed by macrocyclization have some advantages such as high metabolic stability, oral availability, selective affinity, low cytotoxicity. Here is presented the several IMPAS from our database, which I will talk on next slide. Database of antimicrobial activity and structure of peptides is a huge repository of peptides that stores more than 21,000 synthetic ribosomal and non-ribosomal peptides information of their chemical and spatial, also antimicrobial and cytotoxic activities. Here is our address, so you can get in at the moment and check them if you want, as you wish. Database, our database stores 4,757 cyclic peptides, from which only 1,759 are natural. From these natural cyclic peptides, non-ribosomal is 443, ribosomal is 1,316, and synthetic is 2,598. These peptides have various targets, and most targetable groups are gram-positive and gram-negative bacteria. It's interesting what kind of bonds nature uses for cycle formation of peptides. As we see here, for non-ribosomal cyclic peptides, amide bonds and ester bonds are more appears, and in ribosomal cyclic peptides, amide bonds and disulfide bonds are appeared in most cases. For our evaluation, small cyclic peptides represent more valuable drug candidates. Their length varies from 1 till 25 amino acids, and they can be divided into parts: ultra short cyclic peptides and short cyclic peptides, depends of their sequence length. Ultra short cyclic peptides satisfies rule of 5, and short cyclic peptides are beyond of this rule. Length of ultra short cyclic peptides is 6 to 5 2 to 5 amino acids, and for short cyclic peptides 6 to 25 amino acids. Here is presented bonds which are appeared in ultra short cyclic peptides. As we see here, for non-ribosomal peptides, most cycles are created by amide bonds and ester bonds. And here in this pie chart, we see target objects of ultra short cyclic peptides. Most targetable objects are lipid bilayer, quorum sensing, and membrane proteins. These tables, in these tables, we see cycle types which are formed at the synthesis of this natural ultra short cyclic peptides. As we see here, lactams and is the same head-to-tail cyclization, diketopiperazines, lactones, and thiazolidines. We meet in non-ribosomal IMPAS, cyclic IMPAS, and only cyclization we see in ribosomal IMPAS. Here we see a composition of linear and cyclic peptides, and also we have opportunity to compare this different category of IMPs each other, as we see here. As we see here, phenylalanine, tryptophan, isoleucine, and proline are abundant in cyclic peptides than in linear peptides. Now it's a slide about short cyclic peptides, which length is from 6 to 25 amino acid. Total number is 714, and from this total number, only 285 are non-ribosomal cyclic peptides, and 419 are ribosomal cyclic peptides. As we see here, for short non-ribosomal cyclic peptides, most targetable objects are lipid bilayer, membrane protein, and mitochondrial membrane. And for short ribosomal cyclic peptides, most targetable objects are lipid bilayer, this membrane protein, and cytoplasmic protein. Here is presented bond which are used for cyclization of short cyclic peptides. As we see, for non-ribosomal peptides, amide bond and ester bonds are more typical, and for ribosomal peptides, amide bond and disulfide bonds are more typical. Also, ether and imine bond, also disulfide bond, we did not see non-ribosomal peptides. As we see here, here is cycle types of short cyclic peptides, and some of cycles are common for non-ribosomal and ribosomal peptides, like macrolactams, head-to-tail cyclization, also lactones, thiazolidins, and yes, thiazolidins and thiazolines, and there is some cycles which we meet only ribosomal peptides, like cysteines, lanthionines, and oxazolines. On this chart, we see amino acid composition of short cyclic peptides relative to uniprot, like average protein. As we see here, our short cyclic peptides are reached by phenylalanine, also isoleucine, tryptophan, and basic amino acids like lysine, and it's also reached by cysteine, which takes part macrocyclization, and also glycine, which makes the sequence more flexible to create cycles. In conclusion, bonds used to cyclize structure in both ribosomal and non-ribosomal peptides are amide, ester, ether, thioether, and amide bond. Disulfide bond are formed mostly in ribosomal peptides. Thiazolines, thiazolidins, lactams, and lactones have been appeared in both types of peptides, and different systems of synthesis create similar rings, and the protein engaged in these synthesis systems are not homologous, but it can be supposed that they have arisen throughout convergent evolution. Thanks for your attention.
Thank you very much.
So, do you see me or not?
Thank you very much. I see one question, but it's not to you, it's to the previous speaker. So in the chat, there is no more questions. Maybe in the auditorium there are questions and someone.
There is in the chat, Roman.
In the chat?
Yes.
Ah, yeah, okay. From Vladimir Paroykov. Yeah. Could you please summarize the advantages and disadvantages of antimicrobial peptides comparing to synthetic antibacterials?
Antibiotics. Yes. So in general, antimicrobial antimicrobial these bacteria which we use IMPs which we use against bacteria are how can I explain it? Sorry. These IMPs act on big surfaces like membranes and general these organisms like gram-positive or gram-negative bacteria can't be resistant of these IMPs. So general antibiotics works only some specific receptors and yeah, on small surfaces, and this IMPs works on large surfaces, general on lipid bilayer, and that's why bacteria can't have some resistance against this IMPs, as I explained. Yes, so IMPs have undruggable sites and like RNA, DNA, and lipid bilayer, and that's why these organisms like bacteria can't be resistant of these IMPs. And general antibiotics have some druggable sites, and that's why other antibiotics. With other antibiotics, they have some resistance.
Okay. Other questions? And if you compare linear and cyclic peptides with the same sequence, so I mean, what's about the role of the cyclicity of this cyclic structure? How does it affect the activity, the specificity? What do you think about that?
Yeah, maybe some cyclic peptides maybe have some particular cyclic peptides maybe have some low antimicrobial activity, but at the same time they have low cytotoxicity. General rule is that they have advantages than linear peptides because they are more stable against some metabolic processes, and also they have low cytotoxicity. It depends on composition of sequence. Yeah, it's very particular question, and yeah, it's a little bit hard to answer if you don't know exact sequence composition. Yeah, to compare linear and cyclic peptides of particular sequence, but general, yeah, it has some advantages compared to linear peptides.
Yeah, stability is a good advantage, but at the same time, linear peptides are more flexible and more adaptable to the lipid matrix, for instance. Yeah, yes. I agree that in each case, it requires special consideration.
There is a question from audience, Sachin. You see hands.
Yes,
Okay.
Can I ask?
Sure.
Yes.
Sure.
Yeah, thank you. So what is the upper limit of number of residues in case of cyclic peptide? Because number of residue as it increases, cyclization will be difficult, right? So it will create difficulty in penetration to inside the cell or something like that.
Yes. So this deviation, deviation by length was depended on us. I mean, this short cyclic peptides satisfies rule of 5, which means that their molecular weight is less than 500 Dalton. And for short cyclic peptides, we choose 25 amino acids from which weight is from 500 and 2500 Dalton. So this upper limit, choosing of this upper limit was depend on us. So as it was on our decision, yeah. And
second question, ma'am, is what kind of bonding of used in cyclization gives best stability and
okay, sorry. So yes, so as we see, amide bonds and also disulfide bonds are more often in this sequence, and maybe we can consider that these two types of bonds are more stable.
amide and disulfide, right?
Sorry?
Ma'am, amide and disulfide bond, right?
Which bond? It's a little bit hard to hear from you.
So you said amide, 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 and
Amide
disulfide bond.
bond and amine bond, yes.